Morning, Year 12. Today we are learning rates and differentiation. So, we need to go through a few terms first. Let's talk about increasing and decreasing. If a function is increasing, that means that it has a positive gradient, or in other words, that it's always going upwards as you trace your finger from left to right across the graph. It is decreasing with things that have negative gradients, so that is an interval that is always going downwards. Concave up and concave down. A function is concave up if the gradient of each point is increasing, and it is concave down if the gradient at each point is decreasing as you trace your finger from left to right. So there is some diagrams of what this looks like. So the first one, this graph is increasing at an increasing rate because the gradient down the bottom is much shallower than a gradient up here as we're going from left to right. So it is much steeper as we're going towards the right. So that is increasing at an increasing rate. The next one over, these gradients are starting steep, but as you go to the right, they're getting not as steep. So they're still increasing because they're positive gradients, but at a decreasing rate. The next two are the decreasing ones because they have negative gradients. This one is decreasing at an increasing rate because they're getting steeper. And this one is decreasing at a decreasing rate because the gradients are getting shallower. Average rates and instantaneous rates. An average rate of change is the gradient between 2 points. So if we had point T1 and T2 on our graph, we are trying to find the gradient of the line that goes between them, which is the average over that whole time. So to do that, we simply use our 2-point formula to find the gradient. If we are after an instantaneous rate of change, this is the gradient at a particular point, which means that we would differentiate and sub in our x value so that we could find the gradient at that point. Okay, question number 1. A drought hit a region last year and the height of the river H dropped alarmingly over T days, as shown in the graph below. Use the features of the graph below to describe the behaviour of the river height and what happened in the period just prior to the 150th day. Okay, so looking at this graph, we can see that there is a decreasing trend. The gradient is sloping down the whole time. We have different gradients there, but it is always negative. So the first thing I would like to note is that the river height decreased for the whole 300 days. Okay, then we're going to look at different sections of our graph. So first of all, let's look at this part. Okay, so using some of our notation, I could say that that is between 0 and 150 using square brackets because it is inclusive. That section of the graph is concave up. It is also decreasing at a decreasing rate. Okay, now let's look at the next section of the graph, which would be this part. We could call that, in square brackets, 150 to 300. That is concave down. And it is decreasing at an increasing rate. Okay, so looking back at what the question was asking me to do, it said use the features of the graph to describe the behaviour of the river height. So I have done that. Then the last part says, what happened in the period just before the 150th day? Now, if we were in a drought and there was no changes to the weather, for example, rain, you would assume that the water level in the river would be decreasing at a constant rate. You'd expect something to be a bit more linear because you'd lose the same amount for evaporation or feeding animals or watering crops, those kind of things. You'd be using a fairly constant amount of water each day. So for it to do this slowing down process before it starts speeding up in the water loss again, you would think that there would need to be a little bit of rain just before the 150th day to slow down that water loss. So not a lot of rain, but just enough that it has slowed down the loss of water in the river. So that's going to be my last point. So therefore, it probably rained a little, not a lot, just before t equals 150. All right, let's move on to question 2. We want to sketch the graph of the hyperbola y equals 1 over x and describe the branches of the function. So this is our basic hyperbola, which has asymptotes on the x and the y axes. So let's draw those on. Asymptote across here would be horizontal asymptote at y equals 0. Then we have a vertical asymptote at x equals 0. Okay, the curve is going to be in the first and the third quadrant. And if I'm being good, then I would also include a point on my hyperbola to show that I know how to work out the steepness. So if I subbed in that x is equal to 1, I would get y is equal to 1, which is the 0.11. And likewise, if I subbed in -1, I would get -1. So -1, -1 for a point on the other half of that hyperbola. Okay, so now that we have the sketch, we want to describe the branches. So there is two sections of that hyperbola. So starting with this one, using our bracketed notation, we would call that the interval from -infinity to 0, using curved brackets because -infinity is not an actual number, so we always used a curved bracket on that side, and we don't actually reach the 0 because 0 is an asymptote, so we need a curved bracket around the 0 as well. Okay, so from -infinity to 0, this yellow highlighted section, the curve is sloping downwards, so it is decreasing and it's getting steeper, so it's at an increasing rate. So decreasing at an increasing rate. Also could make a note here that it is concave down. In the second section, which should be this bit up here, we are looking at the interval from 0 to infinity, again not inclusive, so round brackets. In this section, the gradients are still negative, so it's still decreasing, but the gradients are getting more shallow as we go towards the right, so that is going to be at a decreasing rate. And this section of the graph is concave up. Okay, so that's all we wanted to do for question 2. Let's move over to question 3. For the first 8 months after its listing, the share prices, which is P in cents, of a new company of avocado marketing, followed the cubic function, the one that is given there, where the time T is in months after the listing. What was the initial share price and the final share price? So the initial share price is when T equals 0. And the final share price will be after 8 months. So that's when T is equal to 8. So I'm just going to sub each of those into my equation up here for P. All right, so for T equals 0, I get P equals 0 minus 4 in brackets cubed minus 12 times 0 plus 100. Okay, you can type that in your calculator, but you should get that that is equal to 36 cents. Do the same thing for T is equal to 8. You'll get P equals 8 minus 4 in brackets cubed minus 12 times 8 plus 100. And this time you get 68 cents. Okay, part B. What were the rate of change of the price and the rate of change of the rate of change? The rate of change of the price is talking about the derivative, so I want to find dP over dt. The rate of change of the rate of change, that's the derivative of the derivative, or in other words, the second derivative. So I need to find those two things. So looking back at the yellow equation, dP over dt, to differentiate the bracket, we're going to bring the power of 3 down the front. You would multiply by the derivative of the bracket, but that's just a 1. Then we keep the bracket, subtract 1 from the power. Then I still have 2 more terms to differentiate. The negative 12t will just become negative 12, and the 100 will just disappear. Now doing the second derivative, d squared p over dt squared. Differentiating the bracket again, the 2 will come down. 3 times 2 is 6. Keep the bracket, subtract 1 from the power, be a power of 1, and the minus 12 would disappear. So that's all we need for B. Part C. When was the share price a local maximum and minimum, and what were those values? So if I'm trying to find maximums and minimums, that means I'm after stationary points, which are when the first derivative is equal to 0. So my first derivative was 3 bracket t take away 4 squared minus 12. Make that equal to 0, and we're going to solve for t. So I'm going to move the 12 to the other side. Then I'm going to divide the 3. Then I'm going to square root, which remember means I need a plus or minus 2, because square root of 4 is 2. Then move the 4 across the other side. So if it's a positive 2 plus 4, we get the solution 6. Or if it's negative 2 plus 4, we get 2. So there is 2 spots where we have turning points at time 2 and time 6. Those would both be in months, by the way. Okay, but that's not the end. We also need to know whether those are maximums or minimums, which means I'm going to sub those into the second derivative to C. So subbing t equals 6 over here, and then I'm going to have a bit of a space, and I'm going to sub t equals 2 on the other side. So in the second derivative, d squared p over dt squared, my second derivative was up here, 6 bracket t minus 4. So it'll be 6 bracket 6 minus 4, which equals 12. Because that is greater than 0, that means it is concave up, or in other words, a minimum turning point. Let's do the same thing for t equals 2. So we get d squared p over dt squared equals 6 bracket 2 minus 4 over close bracket. That will equal negative 12. Because that's less than 0, it means it's concave down, or in other words, a maximum. Now we still haven't quite finished, because the question says, and what are those values? We want the value of the shares at those points, which means we need to find P. The equation for P is the yellow one way back here at the start. I have to sub into there for T equals 6 and T equals 2. So P equals 6 minus 4 brackets cubed minus 12 times 6 plus 100. and calculate that, you actually get 36 again. Then if you do t equals 2, we get 2 minus 4 cubed minus 12 times 2 plus 100, which is equal to 68. So we found two turning points. The first turning point is a minimum. So there's a minimum price at the point 636, and then the other one is a local maximum. These are both local maximums, they may or minimums. They may not be the maximum or minimum of the entire graph, however. But turning points. This maximum is at 268. Okay, moving on to part D, we want to find a point of inflection, which is found by making the second derivative equal to 0. So the second derivative was 6t take away 4 equals 0. And solving that, it's already factorized. The 6 doesn't give us anything. But from the bracket, we would get t is equal to 4. When you find a point of inflection, you need to test it in a table to make sure that the concavity changes. So we have t as our value that we're testing, and we're testing the second derivative, and we're seeing what is happening to the concavity. So I have t is equal to 4. Testing something on either side, I'm going to do 2 and 6 because I actually already know what they are. When I subbed 2 into the second derivative in part C, I got negative 12. When I sub 6 in, I got a positive 12. When you sub 4 in, we get 0 because that's the one we found up here. So that means a negative 12 is concave down, a 0 is the point of inflection, hopefully, and positive 12 is concave up. So because we've changed from concave up to concave down, or sorry, vice versa, that means that there is a point of inflection at, and because it's a point, I need to know the second value, which would be the p-value. So you sub the 4 back into your equation for p, and you'd find that the value here would be 52. Okay, there is still more to this question. We found the point of inflection, but now we want to sketch the whole curve. So the curve on the horizontal axis, which is our t-axis, we're looking at the first 8 months. So let's just go up by 2s. 2, 4, 6, 8. Our vertical axis, which is for the share price, is a little bit more complicated. We have minimum values from the beginning. We knew that the starting value was 36 and the final price was 68. And then we had some turning points in between. So let's put 36 down here, and we're going to put 68 up there. So this is obviously not to scale. And I do also have a point of inflection, which is going to be at 52. All right, so started at 36, at time is 8, our graph will be finishing at 68. We had a turning point, a maximum at 268, and a minimum at 636. We had a point of inflection, or I should say this is a maximum, this one's a minimum. We also had a point of inflection that we just found, which was at 452. And from there, you can see the graph. Okay, so let me just try that again because my concavity doesn't quite look right. Concave down between there and there, then concave up, concave up. That's a bit better. All right, part E, we want to describe the behavior of the price in the different intervals of time using terms like increasing at an increasing rate, increasing at a decreasing rate, etc. So in this graph that we have, there are 4 sections. We have from 0 to 2, then we have from 2 to 4, then from 4 to 6, and then from 6 to 8. They're the 4 sections that we need to describe. So let's start with, and I'm using square brackets because we are at these values. So from 0 to 2, that is a positive gradient and it is getting shallower. So it is increasing at a decreasing rate. The second section is from 2 to 4. We now have a negative gradient, so we're decreasing. And it's getting steeper, so at an increasing rate. Then the next section is from 4 to 6. That is a negative gradient, but it is getting shallower, so it's decreasing at a decreasing rate. And finally, the last section from 6 to 8 is increasing at an increasing rate. Okay, part F. What was the average rate of increase of the share price over the whole 8 months? So that means I want to know the point at the beginning and the point at the end so that I can find the average. At the beginning, we found when time is equal to 0, our graph started at a share price of 36. At 8 months, we found that the share price was 68. We found that in part A of the question. Now to find the average share price change, we're going to use our 2-point formula. So using the points that I've written down there, I will have 68 minus 36 over 8, take away 0, and when you calculate that you get 4, which would be, the units of that would be cents per month. Oops. Okay, so that is the end of exercise 9D.